Thank you ever so much to Hutchinsons for inviting me. Usually if it's something to do with carbon, I can be found hanging around at the back because I'm very sad like that. This is my favourite topic to talk about. And very much this morning what I'm going to try and do and try and cram into 20 minutes are some of an understanding of where are we now in terms of carbon emissions, greenhouse gas emissions that are coming from farms. And more importantly, what can we actually do about it? So we'll start to think about some of the brilliant insights that we've had from Keris in terms of net zero and these ambitions that we have, not just for our industry, but for the UK as a whole. And then starting to look at some of the opportunities that we have in terms of providing those climate solutions, both in terms of how we can hold carbon on the farm in our woody biomasses, but also understanding what the potential is for us to unlock what we can do within our soils. And as Gary's already said, I'm not going to spend a huge amount of time talking about what we do, but we are a farmer-led organisation. We've been active and engaged in this sort of space since 2008. So it's absolutely testament to how many people are here today. We were talking about this when nobody was really that interested about it. So it's fantastic to see the progress and the sort of steps we are in terms of where we are now with people involved. Our fundamental remit in this sort of environment that we are now is to provide those practical tools and resources for farmers. We work with farmers, we're farmer-led, so we were set up by a couple of farmers, and our activities very much are around three key areas. As Gary's already said, a key part of what we do is we measure. So that might be measuring carbon footprints, that might be working in terms of understanding what that carbon balance is for an individual farm or through a supply chain or an area, all those sort of things. But another key thing that we do is we look at what's happening in terms of soils through our soil carbon project, really starting to understand where that baseline is and what the potential is for that farm or that group of farmers to change. A key project that we've got at the moment in this respect is our Farm Net Zero project, which is working with a group of farmers in Cornwall, really starting to understand the potential that farmers have to achieve that net zero goal. So we've got a range of demonstration farms and everything happening there. But also, as well as just those measurement tools in terms of being able to understand where you are now, we also then work in terms of, well, so what? So a key part of what we do is helping farmers and supporting farmers to make those changes that will actually do what we need to do in terms of reducing greenhouse gas emissions, improving soil health, improving business resilience, to really start to equip our farmers or equip you guys to be as sort of ready to go for the future as we possibly can be. Another key thing that we do, and it's something that we're doing a lot more of recently, is communicating the positive. As Keris said at the beginning, our industry quite often gets a kicking when we're talking about carbon, but there are amazing things that are happening that we need to communicate in order to make sure that we're actually telling the good stories. We're explaining what the opportunities are and how our farmers, how you guys are making a difference and the benefits that that's happening, not just for your individual farming business, for the landscape, for environmental issues, and also more widely in terms of addressing what we're doing with climate change. And challenge. So again, working very closely, understanding where are our current knowledge gaps? Where do we need more information? Where do we need more farmer level research to understand actually how do we chuck greenhouse gas emissions in the complex interactions that are happening on farm and actually pull out some meaningful data? So if we just think for a minute about why we should be managing carbon on the farm, well, Keris has already given us a really good understanding in terms of some of those policy drivers and those interactions that are coming in terms of the sort of top-down approach. We also, and I'm sure we'll hear a little bit more as we go through this morning, understand that there is also pressure now coming through our supply chains. And again, it has been slightly slower to manifest itself within arable supply chains than it has within livestock sectors, but it is definitely something that is now starting to be looked at. As industries start to declare their net zero credentials, a key part of them being able to achieve that is actually working with their suppliers. But from an individual business perspective, managing carbon on farm makes business sense. There is an incredibly easy relationship between efficient uses of resources and cutting your carbon footprint. So if you do, and if you start to manage carbon on the farm for no other reason, there will be opportunities to cut costs. It allows you to be more informed and make better decisions, as I've already said, when you're starting to think about where you might want to take your business in the future. As well as thinking about it from a practical and a financial perspective, you can also have an understanding of what the impact of those management decisions will be on your carbon footprint. It creates more resilient businesses. It provides that positive narrative, as I've said already. It allows us to be more future-proofed. And as Keris mentioned earlier, there are also potential income generation opportunities, and that might be through accessing our voluntary carbon market, that might be through incentives that come through new government policy or through supply chains, but it may well be that carbon is something that is included with what we get paid for in the future. So where are we now? In terms of where are our farmers, especially in our arable sectors, in terms of where are those emissions currently coming from on the farm? And with a caveat that there's no such thing as an average farm, I'm going to break all my rules for a minute and pretend that there is. And if we were to pretend that we have an average farm, then that's where the emissions are basically coming from. And you can cut this pie in lots of different ways, depending on whether you're including your Scope 3 emissions, and there can be different names for the categories. But on average, on an arable farm, 60% of your emissions are coming from nitrogen. Okay? About 20% are coming from sort of fuel use and field operations. So from some of the carbon emissions that we are losing through that cultivation that Steve was just talking about, the emissions that are coming from the diesel that's fueling our tractors. About another 10% coming from sort of any P&K, manure, lime, that sort of stuff that we're using. Just under 10% from sown seeds, and then a very small percentage from crop protection. Now, a couple of things to remember here. We're not just producing these emissions for the sake of producing these emissions. We're producing these emissions because we're producing food, okay? And that's a key part of the discussion that needs to not be lost. Keris already mentioned it earlier in terms of the importance of making sure that we don't export our issues. We actually look at the opportunities that we have on farm to become more resource use efficient and really start to look at what we can do. So that's how it tends to work. Now, obviously, we have a carbon calculator, and one of the exciting things for us, with more people starting to get involved in this, is that we've now started to get a huge amount of farmers using the carbon calculator. So we've got lots of exciting data. So that's the sort of pie chart that I usually put up. But actually, this one here says, well, from all of the arable farms that are using the carbon calculator, that's where we sort of are now. So again, really starting to look at inputs, nitrogen, a key part of something that we need to look at. And again, also starting to think about those nitrous oxide emissions that are coming from any use of organic manures or those sort of things which are on the farm as well. And if that doesn't convince you with that slide, then potentially here are some real carbon footprint examples. And again, it doesn't really matter what the sort of bottom number is in terms of the total emissions. What we can see with all of those is that emissions associated with inputs is the predominant category. Going back to a point that Keris made earlier, the other important thing to think about is what KPI are we using? Are we providing our carbon balance or our carbon footprint at a farm level? Which is absolutely great as a starting point. Are you already carbon positive, carbon negative, all those sort of things? But if we're starting to compare across farms and look at a little bit of benchmarking, are we doing it in terms of on an area basis, in terms of emissions per hectare? Or are we doing it in terms of emissions per tonne of product? And I would totally agree with Keris in terms of we need to do it both ways. The other important thing here is actually about making sure we are taking the full understanding of everything that's happening on the farm. So here, again, we can see our gross emissions. So that's just looking at the emissions coming from the farm. And then actually when we also include the opportunities that farmers are in terms of delivering those climate solutions. And the interesting thing here is that you can see that the actual number in terms of the carbon balance reduces drastically when we start to make sure that we're taking full and accurate account of carbon sequestration. And again, that's just worth thinking about in terms of any footprinting and that sort of thing which is coming through the supply chain. Is it providing that accurate picture? But again, looking at it per tonne, again, looking at just on the gross over there, which is just looking at emissions, we've got an average there of, I can't actually see what it says, 0.45. Again, these are reported in terms of tons of carbon dioxide equivalent. So not all of these emissions are coming from carbon dioxide, but we have to convert those emissions that are coming from nitrous oxide into what they would be in terms of their carbon dioxide equivalent. And again, if we then look on a net basis there, where we're also taking account the sequestration, again, that figure comes down. So this is great. But again, as we've said, there's not one magic management practice that all farmers can do that's going to solve the problem. Each of your farms is unique. Each of your farms is a combination of what's under the soil, what falls out the sky, and what you do in the middle. And so we have to take account of the fact that we're dealing with these complex biological systems that actually our potential to be able to make a change will be governed by our weather, our soil type, and everything else. And just to highlight that fact, there's just one slide here, which is some work that's been done by AHGB, looking at the carbon footprint of a variety of different cereal crops, depending on region. And again, you can start to see where some of that variation is, which will be due to some of the things that Steve's been talking about around soil type, also climatic conditions and end use. So that's great. But what can we actually do about it? And what are the opportunities that we have on farm to actually make a difference? And I know that it can really seem all-encompassing and overwhelming in terms of the options. It can also be something that often there's quite a lot of preconceptions in terms of, you're going to tell me I can't do this, and I can't do this. And actually, I have to stop using that, and I have to not do that anymore. Whereas in reality, there are huge amounts of things that you can do that will make a difference both in terms of cutting your carbon footprint and also reducing your costs and improving your resilience. And if we think for a minute about that complexity that Keris spoke about and the fact that we are doing this within this biological system, and this is actually a graphic that's come from the NFU paper in terms of achieving net zero that we've already heard about this morning. One of the other things that we have to remember is that unlike other sectors, which basically have a lovely concrete box around everything that's happening and they can control everything that's going on within it, we are dealing within this complex biological system that is inherently leaky. So if we were to go out tomorrow and hoover off all agricultural activity, our landscapes would still be producing these gases as a result of our carbon and nitrogen cycle. So like Keris was saying earlier, we're not going to be able to totally eliminate all of our greenhouse gases. The other important thing to remember is the different way that these gases behave. So the difference between carbon dioxide, which is obviously emitted during farming, but also we have the opportunity to take that up, as Steve's already been telling us, through how we manage our crops and our soil. But the emissions that we have associated with nitrous oxide and methane can be much harder to offset, because they're linked to those biological cycles. And again, I think as has been mentioned this morning, there's not been a huge amount of attention on nitrous oxide as a gas, but it's incredibly potent in terms of its ability to cause global temperature rise, 298 times more potent. And 80% of it comes from agriculture. So it's certainly something that we will be hearing a lot more about as we transition through the rest of this year. So what are those key mitigation options that arable farmers have? They can sort of be put into three different sort of camps here. One very much focusing on energy and fuel use. So again, thinking about what we can do in terms of reducing our fuel use through looking at tillage operations, through looking at efficient use of machinery, maintenance, tyres, machinery choice, all that sort of thing, as well as what comes next in a few years' time when we've got that research and innovation and technology that allows us to start to move away from fossil fuels for our cultivation and our farm-based equipment. Again, thinking about that, we've got the idea around more utilisation of precision agriculture and tillage practices, again focusing very much on reducing those emissions from nitrous oxide. So what can we do about precision nutrient management, precision soil management, understanding the conditions and the capability of our fields and within field variation to reach those yields that we need. And also starting to look about how we can reduce those nitrous oxide emissions that are coming from within our soils. So how our soils are structured, actually, are we providing the conditions where the nitrogen is much more at risk of being lost? So we really come back down to this idea of nitrogen. And whichever way we cut that pie, in terms of emissions on farm. Nitrogen is a huge part of that carbon footprint. So focusing on nitrogen is a really good start. Now, it can be really difficult to unpick, because again, thinking about these complex biological systems, again, if we start to think about nitrous oxide, it can be difficult to unpick within that nitrogen cycle where we might be able to focus. And again, thinking about the fact that we're not going to ever totally eliminate it. And again, it's not just agriculture that's producing it, it's all land use. Nitrous oxide will be being produced. And again, whether that nitrous oxide is lost as part of that nitrification process or the denitrification process is all linked up in terms of how much water is within your soil and that microbial activity. And a way to think about nitrogen and nitrogen losses from the system is a little bit like a leaky pipe. And that's, what this diagram is sort of trying to illustrate there. In the fact that it's always going to leak. But the speed that that nitrogen is going through the pipe depends on how much you put in at the front end, the rate and the source of that you put in, and what the sort of soil conditions are like in terms of where that's going to be lost. And that's where we do have opportunities to start to look at how efficiently we can keep hold of it. So a small percentage of every fertilizer application is going to be lost. But actually, if we can focus on using nitrogen well, both for a greenhouse gas emissions reason, but also from a yield and economic perspective, then we're going to reduce the amount of excess nitrogen that's in the system. And there is clear evidence that that will optimize what's happening in terms of our greenhouse gas emissions. So what can we do about it then? Well, some key principles to start thinking about. Number one, really trying to match timing of plant uptake and nitrogen supply. Now, hopefully this is not rocket science or new to any of you guys. Okay, this is what you're trying to do in terms of that optimal nutrient management. And again, trying to make sure that we've got very little of that nitrogen that's hanging around in the system, where especially at those risk times, in terms of when our soils are wet or when they might be at risk of it being lost. Now, there obviously is some new technology, although the science is not new in terms of the sort of inhibitors. And that's very much what those inhibiting products are really trying to do, in terms of slow the time frame that nitrogen is flowing through the pipe. So it's more of a dribble rather than a flow, rather than a rush through. But also, those applications that are going to be those high-risk applications of loss are very much those spring applications, when our soils may well be waterlogged, our soils may well be cold, and actually the ability of those soils to be able to take up that nitrogen might be slightly suppressed. So really focusing on that first, those targeted applications in the spring is a good place to start. Now, I'm not saying that we don't need to apply nitrogen, okay? And as Steve has already said, there is some really good evidence that says that actually, nitrogen is very important in terms of optimizing both our crop yields, but also the ability of that crop to perform effective photosynthesis and pump some of that back down into our soils in terms of what's happening with carbon. So understanding that nitrogen response curve and where you are and where your applications put you on that nitrogen response curve is a key part of that. So again, really starting to think about not just that at the start of the season, but adjusting it all the way through. So it's not just we set it up at the beginning, we're constantly monitoring that to see where our crops are, whether they need to be pushed forward or what we need to do with them. And then also thinking about fertilizer type. And if we start to think about the opportunity for mitigated fertilizer, so that's where the energy that's associated with the manufacture of that fertilizer is mitigated either through the use of renewable energy or through something else. And as we start to look at what's coming down through the supply chain and those supply chains that are declaring their net zero credentials, it may well be a requirement of that supply chain that you have to use some of these mitigated fertilizers. Now, it wouldn't be a talk that I gave if I didn't witter on about soil. Okay, now, so what about soil health? And actually, what's the impact in terms of how we manage our soil on what happens and how effectively our soil utilizes those nutrients that we put in there? And if we think about what we're trying to do in terms of that sustainable soil management and making sure that we are optimizing the conditions both for our soil physical health, our soil chemical health, and also our soil biological health, then actually If we can do that, and if we can really start to focus on our soil health, then that will improve our rooting, it will improve our nutrient use efficiency, and it will help to reduce our greenhouse gas emissions. And an investment in your soil health is an investment in your farm's effectiveness and resilience. But also, if you are starting to look at improving your soil health, does that therefore mean that you can push the limits? So in terms of thinking about, actually, can you start to pull back on some of those nitrogen applications? Are your soils ready to do that? And as part of the work we do with the Soil Farmer of the Year, it's been really interesting over the last couple of years to start to see that actually, as we move forward, reducing nitrogen and actually having very little impact on overall yield has been something that a lot of the farmers that we've been recognising through that competition have been striving towards. So it is possible, but again, it's that understanding of when to push the button and actually how ready are your soils to start to do that. Are they biologically active? Are they in good structural health? And can you start to look at that targeted reduction of nitrogen and without that impact on your end product? And again, this is where really starting to share information and knowledge is key. Because there are things to understand how people are doing it and what you might be able to take away, and that's a key part of what we do with Soil Farmer of the Year. So just also in terms of energy costs and energy usage, and it can be something that actually never gets focused on when we think about what we're doing. It's just something that can seem to be insignificant. But if we look at where we are with energy costs and what's going to happen in terms of the fact that they're going to significantly rise, as well as potentially availability decreasing, we're dependent on them at the moment. We're dependent on fossil fuels. And actually our profitability is also partly dependent on those power and input costs. So if we can reduce our overall energy use, we can not just reduce our costs, but also look at that greater energy resilience. And across the thousands of farms that we work with in terms of carbon footprinting, we've yet to find somebody that we can't start to get those reductions with little or minimal impact on end use. And just a couple of examples of that. In terms of, this is one of the examples that I showed you at the beginning. And again, what we looked at there was actually we've managed to get a 10% reduction in their fuel use, which doesn't just save them 10 tons of carbon in terms of that greenhouse gas emission reduction that we've been talking about, but also provides £2,000 annual saving. So you don't have to be doing it for the carbon reason. You can just do it for the financial reason. And again, looking at what we're doing, we were looking at actually changing establishment and cultivation for one crop within the rotation. And again, thinking, obviously, again, bewaring the law of averages, about 105 litres of red diesel per hectare is an average that's used. So again, if you can reduce that by 10%, then you can reduce your red diesel usage, by 2% per kilo of grain sold, and you can save over, £2,500. So again, financial options that are there for you. So how can we measure this sort of thing? And again, it wasn't the focus of what I was talking about today. But actually, managing carbon on the farm starts by understanding where you're currently at and providing that baseline. And then what the best opportunities are for you, you can then start to look at that in terms of what-if scenarios and scenario planning. So you can start to see where are you going to get the most benefit in terms of greenhouse gas emissions reductions? Where might there be opportunities that also you can align that with economic savings at the same time? But as Keris has already said, we don't have all the answers yet. We are making really good progress in terms of understanding how these gases behave, but it is a complex system, and because we're all different, we all have different farming systems and soil types and all those sort of things, we're never going to have all the answers. But that's very much where getting a starting point and actually starting to provide that feedback and that sort of, well, actually, this is what I want to know. This is what I want to know. What is the impact of this species of cover crop versus this species in terms of not just how much nitrogen that's providing me, but what it's doing for my soils? And really starting to challenge our researchers back to say, well, this is the information that we need so that we can make better management decisions is a key part of that. And remembering also that it is a leaky system. Okay, so we're never going to totally eliminate all of those emissions, but we are the only industry that has that solution. But at the same time, thinking about it from those benefits in terms of improved efficiency, a reduction in your cost, and future-proofing your business that makes you more resilient. So just to finish off, we are one of the sectors that are at the front line in terms of the direct impact on our business from the impacts of climate change. We've not really spoken a lot about adaptation this morning, but as our climate starts to change, I'm sure all of you will have experienced some of this, it has a direct impact on what we do day to day. But we are also that industry that can deliver those solutions. So some key things to think about. Understand your baseline. What is your current carbon footprint? Where are your main sources of emissions? And what can you do about it in the short, medium, and long term? Think about what those options are that you have and what impact it will make. Is it aligning with where you're trying to go anyway? Look for the easy wins first. So again, quite often when we work with farmers, you think you're going to have to make these massive changes. Start small. It's a marathon, not a sprint. Okay? This is the start of your carbon journey. And actually, the end point is almost in some respects yet to be decided. But just start, because then you can start to get an understanding of what's happening on your farm. And as I say, provide that positive message for our industry and just get involved. Thank you.
Brilliant. Thank you, Becky.